So in this question, we're told that it's been 1,000 million years since we began with our half a kilogram of uranium-235, or 500 grams, right? And so how much is remaining after 1,000 million years? So this time we're not given the half-lives amount, we're actually given the years. And so how do we go from years to the amount remaining, right? Now remember, we have a formula, a pretty cool formula that we already figured out, that tells us if we have the number of half-lives, we can figure out the amount remaining, right? We just figured that out in the last question, right? Right, which is great. But the only question is, how do we go from the years to the number of half-lives? If we can figure out how to go from, 1,000 million years to half-lives, then we can take that number and plug it into our formula and get the amount remaining. But how many half-lives is 1,000 million years? That is the trick. That is the trick. Can you figure that one out? Take your time. Yes, how many half-lives is 1,000 million years? Well, don't look at anything. Stop everything and just look. Yeah, okay. So, one half-life is 700 million years. Two half-lives is 1,400 million years. Three half-lives is 2,100 million years. So anyone watching from home, press pause in the video and see if you can figure out by yourself how to go from 1,000 million years to half-lives, right? Because that's better than just memorizing a trick. Like, does it make sense to you, and how would you get there, right? So I hope you've all pressed pause in the video and tried that. I'll just show you now. The trick is, if you take 1,000 and divide that by 700, right? We get approximately, I'll do it right now, 1,000 divided by 700. We get approximately 1.43. Can you see that? Or about 1.4, let's say. So 1.43, roughly, okay? And that is the answer. It's about 1.43 half-lives. It's a little more than 1, and it's less than 2. Because think about it. 1 half-life was 700 million years. 2 was 1,400. So 1,000 million years is in between 700 and 1,400. And so it's got to be in between 1 and 2 half-lives, right? Make sense? Okay, cool. Cool, and so now that we have that number, we can use our formula we figured out earlier to get the amount remaining. So what's the amount remaining? Take your time. Yep. So we go 500. Yep. Yep. 500 times a half to the power of 1.43. Excellent. No bother. And I'm going to do it, like, to put this in a calculator perfectly, I would do this. I would go 500 times 0.5 to the power, and instead of 1.43, I'm going to do this. Watch this. 1,000 over 700 in parentheses. So your calculator, which understands PEMDAS, is going to do the parentheses. It'll divide these to get the 1 point. It's actually 1.42857, yada, yada, yada. And then it's going to go power of 0.5 and then times 500. So this is the perfect way to do it. But honestly, you guys, if you just did, to the power of 1.43, you would come up with a number that I would, on my quizzes, would be correct, okay? Because it's not exact in this case. It's just like a piece of radioactive material decaying. It's roughly, even the half-life of 700 million years is already an estimate. So this 700 million years has already been estimated. That's not exactly right. And so I'm not going to hurt you badly if you made a little error on a test or whatever. But this is the perfect way to do it, though. That would give you the most accurate answer. But 0.5 to the power of 1000 over 700, and that is roughly. And then again, I'll ask you all to just round to the nearest gram. It's 180 what grams? Beautiful, 186 grams, lovely. And if you did like 500, times say 0.5 to the power of 1.43, again 186 grams, right? See that? So it's you're going to get 186 grams either way. Okay, beautiful, good work.